Welcome back to The Explainer. Today, we're doing something a little different and honestly pretty fun. We're diving into a math chapter that seamlessly takes us from basic, everyday counting all the way up to division, and it does the whole thing through a super relatable story. If you've ever wondered how to make complex math concepts just sort of click organically, well, you are definitely in for a treat today. Let's get into it. Here is our roadmap for the breakdown. We'll start with the Festival of Math, move into from addition to multiplication, check out skip jumping on number lines, explore the magic of tables, and wrap up with grouping and dividing concepts.
All right, part 1, the Festival of Math, where we ground these concepts in reality.
So, we kick things off with a family getting ready for the Raksha Bandhan festival. This is such a smart way to naturally introduce the need to count. We meet characters like Gopal, Dara, and their beloved Atya, who are busy cleaning and decorating the house. Notice that before any complex equations are even mentioned, the learner is simply asked to observe and count everyday items around them. Leaves, glasses, pomegranates, flowers. It establishes a really important baseline. Math isn't just for tests, it's something we use in our daily lives, especially when we're celebrating.
Moving right along to section 2, from addition to multiplication. This is that core aha transition moment.
As the family is sitting down and actually putting these 5 Rakhis together, the text drops a super simple but highly strategic question on us. If we're making 5 Rakhis and each one requires a certain number of threads, well, how many threads do we need in total? This creates a genuine, practical need for a faster way to calculate. We aren't just being handed a formula to memorize, we're given a real problem that practically begs for a better solution. I mean, imagine trying to solve this the hard way, 2 threads plus 2 threads plus 2 more. You'd be dealing with a tangled mess of thread and numbers before you knew it. But that friction, totally intentional. It makes the switch to multiplication feel like a profound relief. Suddenly, 5 times 2 equals 10 isn't just some arbitrary rule. It's a mental shortcut that solves an immediate, tangible problem. The crucial takeaway here is that multiplication isn't introduced as this scary, isolated new concept. It's defined incredibly simply. It's just an efficient shortcut for repeated addition. By building this foundational logic first, the text ensures you truly understand the mechanics of why multiplication works, rather than just forcing you to memorize how to do it. Okay, section 3, skip jumping on number lines. Let's visualize those jumps. To keep things engaging, the textbook introduces a physical game. Dara literally skip jumps along a track on the ground, while Gopal tracks the data in his notebook. It is so cool how they take the abstract idea of multiplication and map it directly into physical space. You can literally see the math happening. And look at how neatly this works out. The physical jumps map perfectly onto the 3 times table. Just look at the progression here. 1 jump lands on 3. 2 jumps of 3 mean 3 plus 3, which gets you 6, which is exactly the same as 2 times 3. The arithmetic is visually linked to the action, so the student is essentially building the times table themselves, step by step, instead of just staring at a pre-made chart. Then, the chapter completely flips the script with a pretty clever puzzle. Astea places a flower way out on the number 12. Now, you have to skip jump with equal steps to reach it, no direct jumping allowed. And the goal? Reach it in the absolute smallest number of jumps possible. This is fantastic because it sparks active problem solving. It's subtly forcing the learner to reverse engineer the multiplication they just learned to find the most efficient path. They have to stop and ask, okay, what number multiplied by something small is going to get me exactly to 12? Which brings us to section 4, the magic of tables, where we highlight mathematical patterns. All right, get ready for a real mind-blown moment. Check out what happens when you line up the 2, 3, and 5 times tables side by side. Look at the magic hiding in plain sight. Adding the products of the 2 times table and the 3 times table perfectly gives you the 5 times table. 2 plus 3 is 5. 4 plus 6 is 10. 6 plus 9 is 15. It's brilliant. It shows us that math isn't just a bunch of disconnected rules to memorize. It's a deeply interconnected language. And the best part? You can scale that exact same logic way up. The text challenges you to figure out how many spokes are in 30 wheels, assuming each wheel has 5 spokes. Instead of panicking over a big number, you break it down. 10 wheels have 50 spokes, right? So 30 wheels is literally just 50 plus 50 plus 50, which gives you 150. It proves that tackling massive, complex problems is just an extension of those foundational patterns we just uncovered. Finally, section 5, grouping and dividing concepts. Time for some rapid-fire application of these skills. Watch this beautiful breakdown of a problem about a character named Kanu making seashell necklaces. He starts with 112 shells in total, and he needs 28 for a single necklace. So what does he do? He subtracts 28. Then he subtracts 28 again for the next one. Do you see what's happening? Division is being introduced here simply as repeated subtraction. It brings the entire learning journey full circle, perfectly mirroring how multiplication was introduced earlier as repeated addition. It's just a really, really satisfying connection. To wrap it all up, we get hit with these rapid-fire real-world scenarios. We're figuring out cookies in jars, counting auto rickshaw wheels, calculating how long it takes to save up rupees, and even making change for a 500 rupee note. It demonstrates how this logical framework we've built doesn't just live on a chalkboard, it actually helps us decode everyday life. Think about it. What started as simply counting leaves and flowers for a local festival has organically blossomed into mastering scaling, multiplication, and division. So, as you go about your day today, I want to leave you with this to ponder. How might these exact same foundational mathematical patterns be hiding in plain sight in your own life? Keep your eyes peeled for those hidden connections, and thanks for hanging out with me on this explainer.